up to this slide. We said that you try to remember. We said that the strength of concrete, okay, the shear strength of concrete will depend on the relative amount of V and M. Okay, so if the V and M changes, the strength of the concrete will also change. And how that will change, that will be the discussion of today. But before that, I just want to review one more thing that we discussed in the last class. That the diagonal cracks, okay, the diagonal cracks will be formed due to the shear, right? The cracks that are inclined roughly at an angle of 45 degrees, those cracks we call them diagonal cracks, and they will be formed mainly due to the shear force in the beam. Now, if I take a section here, as you can see here, in this particular section, if I see this diagram, okay, if I see this diagram, you can see that this is close to support, and that's why the amount of moment is not significant, but the amount of shear force is significant. So in this case, that will be forming due to the shear. So we will see a diagonal cracks only, not see vertical cracks formed by flexion. And what we said in the last that these diagonal cracks, when they are near the support, they will form at a place near the neutral limits, because near this the shear stress is maximum, and this will propagate upward and downward. So it will arrest from propagating to upward at certain, if the beam is sufficiently deep. Okay? Beam is a deep beam. At certain point, it will not move upward anymore.
Sir.
The beam is. Hello.
Sir, কথা আটকে যাচ্ছে।
কথা আটকে যাচ্ছে। স্যার আমি হেডফোনটা লাগাই, ওয়েট করুন।
Hello, can you listen to me now? এখন শোনা যাচ্ছে?
জি স্যার, এখন ক্লিয়ার।
Okay, so what we were discussing is if your beam is a deep beam, okay, so if you have sufficient depth compared to the span, okay, of the beam, or in other words, the depth to span ratio, if it is high, in that case, this crack at certain point will move, will stop propagating upward. Okay, সেটা কেন, সেটা আমরা একটু পরেই ডিসকাস করবো ইনশাআল্লাহ, সেটা একটু পরেই ডিসকাস করবো। But for now, just it will be good for you to understand that if the beam is deep enough, then the crack will move upward, but at certain point it will stop moving further to the top. If the beam is a shallow beam, okay, that means if the depth to span ratio is very small, in that case, this crack will move upward very rapidly. Okay, and there is a good chance that the beam will split into two halves. So by two halves I mean like just on the two sides of the crack there'll be two halves of the beam, and that failure will be a very sudden and abrupt failure. And in the downward direction, if you have longitudinal reinforcement or main reinforcement, this crack will move to the will near the longitudinal reinforcement, and it will become horizontal. So the crack near the longitudinal reinforcement will become horizontal. Okay, so it will not further go downward. If you have this longitudinal reinforcement, it will be horizontal, and this is because of the dowel action, the longitudinal reinforcement. We will be talking about the dowel action, we will be seeing in figure as well, inshallah. So this longitudinal reinforcement will give a property to the beam which we call dowel action, and this dowel action will allow the crack to move in parallel to the longitudinal reinforcement. So this is in a way good for the shear. Okay, good for the shear resistance. Why? Because if you think about this, if I want to show you here, if the crack moves in this direction, okay, this path is smaller compared to this path. This path is larger. So if the crack moves in this direction, the failure will be more rapid. If the crack moves in this direction, the failure will be less rapid. So this is in a way good for the beam. It can, because of the presence of the longitudinal reinforcement, the shear failure can be delayed to some extent, but it's not the ultimate solution. Obviously, you need the shear reinforcement. Still, you need the shear reinforcement to hold these cracks from propagating, further. Now, if you choose a location where the shear force and bending moment, both of them are large. Okay, say for example, if I think of this particular beam, where near the near the midspan, the shear force and the bending moment, both of them are large. Okay, in that case, the initial propagation of the crack will be due to the flexure. Okay, so the flexure crack will develop first, and then the wave crack or the diagonal crack will also develop near the near the neutral axis. Okay, and these two cracks, this vertical one and the wave crack formed near the neutral axis, they will march together. Certain point, they will march together. Okay, so this is the crack when you have both V and M, or in other words, the shear force and the bending moment in a significant amount. Now, how the strength of concrete will vary depending upon the shear force and bending moment, that is the question now. So I will just give you two values, okay, and then I will discuss why these values are like this. So when the bending moment is less, okay, so listen to this very carefully, it's very important for you. When the bending moment is less and shear force is large, in that case, the shear strength of concrete, so I'm talking about the shear strength of the concrete only. Okay? So this is the shear strength. VCR is the shear strength of the concrete that you can represent with this equation, 3.5 square root of FC prime. Okay, Why we represent with the square root of FC prime? Because it is easier to measure the value of FC prime. We can easily measure the value of FC prime using just a simple cylindrical compressive strength test, right? So that's why if I know the value of FCR, you can guess or you can predict what will be the value of the shear strength of the concrete. Okay, and we did it for many other things. We have discussed many times that the split tensile strength of concrete is 6 to 7 times the square root of the compressive strength of the concrete, and the direct tensile strength, or the true tensile strength, okay, will be 50% to 70% of the split tensile strength. So this value in that case will be 3.5 to 5 square root of FC prime. And similarly, you can represent the shear strength of concrete with this equation. Okay, if you know the value of FC prime or compressive strength of your concrete, cylindrical compressive strength of your concrete, then you can get the value of your shear strength using this equation. So this equation is only applicable when you have a small m, okay, when the V is only significant. All right, so this is one thing. And the other thing is, the other equation is when you have both V and M large. So if your V and M, both of them are large or significant, in that case, the factor here, 3.5, will reduce to 1.9. So the equation will then be 1.9 square root of FC prime. Okay. Now my question to you, anyone can answer, why the factor has reduced when you don't have, when you have both of them, V and M, significant? Why the factor reduced? Can anyone answer? Hello students, can you listen to me? Can you listen to me? আমার কথা শোনা যাচ্ছে?
জি স্যার।
ফ্যাক্টরটা কমে গেল কেন? কেউ আনসার দিতে পারবা? Any guess? Any guess? So this is for small m and large v, and this is for both large V and M. So when both of them are large, the equation will be this one, and the factor will be a smaller factor of 1.9. Okay, answer dite parba? Okay, I will give you the answer inshallah. So because if you think very carefully, as I said before, that for V and M, when this is large, the crack initiation will be due to the moment, right? The initial crack will be formed due to the moment or flexure. So what will happen in that case? And later on, the shear force, the crack will form near the neutral axis because of the shear force. But when the crack forms because of the shear force, what you will find, you will have already some area loss in your concrete section. So some of the area will be lost or will become ineffective because of the cracking due to the flexure. Okay, because and for that reason, the area that will be effective to resist the shear will become small, and for that reason, the shear strength of the concrete will also reduce. কথাটা কি বোঝা গেছে? In this case, the crack initiation will be for the shear. There is no crack for the flexure. So the effective area is much higher. Effective area available to resist the shear force is much higher in this case compared to this case. The effective area available to resist the shear in this case is lower because there is already some area loss, okay, because of the cracking formed by the flexure or formed by the moment. বোঝা গেছে জিনিসটা? সো যেহেতু অলরেডি কিছুটা ক্র্যাক এখানে ডেভেলপ করছে, ইফেক্টিভ এরিয়াটা কমে গেছে শিয়ার রেজিস্ট করার জন্য, দ্যাটস ওয়াই দ্য স্ট্রেংথ অফ দ্য কংক্রিট উইল অলসো রিডিউস। ওকে, বোঝা গেছে?
জি স্যার।
আচ্ছা, now there is a general equation provided by ACI 318. Okay, this general equation will cover all the cases. Okay, so if you just simply know the value of V and M, okay, so your V can be high, M can be low, both of them can be high, both of them can be small. So in that case, just plug in the values of your V and M, and obviously you have to plug in the value of the reinforcement ratio. So this reinforcement ratio is the longitudinal reinforcement ratio that you have, the longitudinal tensile reinforcement ratio, the value of the effective depth of your beam, okay, effective depth D of your beam, and the compressive strength of your concrete. If you know all these values, then if you plug in all the values, then you will get the value of your shear strength. Then this strength will be the value that you obtain from this equation should always be less than 3.5 square root of epsilon. That is this one. So this is the maximum shear strength that you can attain. So the maximum shear strength will be attained when you don't have any moment. Okay, so in that case, your value of shear strength of concrete will be this one. So this value should always be less than 3.5 fc prime. Okay, and if the value is, say for example for this one, okay, if the value is significant, the value of V, if it is significantly if the value of M, if it is significantly large, okay, if it is significantly large, then obviously this term will become close to zero, or this term will become very insignificant, because m যদি অনেক বড় হয় তাহলে এই পুরো টার্মটা ছোট হয়ে যাবে. In that case, the value of VCR will become close to this value. So 1.9 square root of FC prime, right? So actually this equation, the whole one, purata, this will cover up all the shear force and bending moment. So if you know this equation, this is sufficient for covering up all the shear force and bending moment. Now in this this equation can also be expressed with this graph. Okay, graph দিয়ে express করা যায়. এখানে দেখো যে আমার কোএফিসিয়েন্টটা, this is the smallest, okay, when this ratio is close to 0. হ্যাঁ, আর এই রেশিওটা 0 কখন হবে? যখন your m is significantly large, then this will become this coefficient will become 1.9. and যখন তোমার then with the changing of your V and M, okay, you can have different values for your compressive strength of concrete, and this value will become again maximum, or the coefficient will become 3.5, okay, at certain point, especially when you have large V and small m, then this coefficient will become 3.5. okay, আচ্ছা এই কোশ্চেনটাই আমরা এখানে আরেকটা তোমার হচ্ছে ফিগার দিয়ে দেখানো হয়েছে. This is from a paper. So this paper actually, they have plotted many points, so they did many tests, and these points are the test data, and you can see that these points agree with the equation. Okay? Although there are a lot of scatter, পয়েন্টগুলি অনেক scattered যদিও, but roughly these points follow this equation. That's just the equation that we showed. Okay? This equation, these points roughly follow this equation. Okay, now behavior of diagonally cracked beams obviously you need the shear reinforcement for the diagonal cracks. Okay, you need the longitudinal reinforcement for the flexural cracks, but the longitudinal reinforcements cannot fully prevent the diagonal cracks from being formed. So to prevent the diagonal cracks from being formed, or to limit the propagation of the diagonal cracks, you need the shear reinforcement or the vertical stirrups. Okay, and as I discussed before, that the failure types in beams can be of two types. The diagonal the failure for diagonal shear crack will be of two types. If the beam is a shallow one, the beam is a shallow beam, that means your depth is small. In that case, your propagation of the wave shear crack will become very rapid and it will move to the top, and the beam will fail very rapidly. If the beam is deep, okay, the propagation of the wave shear crack will be less rapid, or in other words, it will stop at certain point. Okay, on the top it will move at certain point. এটা কেন মুভ করবে না একটা পয়েন্টের পরে, এটা ডিসকাশনটা আমরা এখানে একটু দেখে নিই। Because in a deep beam what you have, যখন বিমের ডেপথটা অনেক sufficiently large থাকে, okay, say for example this depth is h, or you can say the d value, the effective depth, okay, effective depth, if d or h, if this is large, in that case what will happen, the crack will keep propagating, but because there is the compressive force here, okay, and if your beam is a deep beam, then this compression block will be comparatively large. ঠিক আছে, যদি shallow beam হয় তাহলে compression block will be comparatively small, right? Compression block এর amount টা কম হবে, so the compressive force on this compression block will be higher in this particular case. যখন আমার এরিয়াটা বড় হবে, এই যে আমার কম্প্রেশন ব্লকের যে এরিয়া, এখানে যে y depth দিয়ে দেখানো হয়েছে, this y depth when it is large, okay, when this y depth, when it is large, then the compression block is large, and in that case the value of cc or compressive force will be significant, will become considerably high, and this compressive force will hold the crack from moving further upward. এই compressive force এর কারণে যেহেতু এটা প্রেসার দিয়ে রাখবে এদিকে, so this crack will not be able to open up further upward. Okay, so that is the reason. But if the beam is very shallow, then this compression block will be also shallow. The compression block will be shallow. In that case, the cc will be small, and this will not be sufficient for holding up the crack, and the crack will move easily upward and cause the beam to fail, abruptly. So এই জন্য আমার deep beam এ abrupt failure টা we can resist to some extent, but even though we have deep beam, we should reuse the shear reinforcement, because uh, I will show you, I've shown you one figure. If you remember this one, you can see the difference when you have the shear reinforcement and when you don't have the shear reinforcement. So in this particular beam, this part of the beam is reinforced with shear reinforcement. These vertical stirrups, these red lines, these are the shear reinforcement, and this part of the beam you don't have any shear reinforcement. So what happens in this part, you see the crack. This crack is very large, and it looks devastating, so it can at any time cause the beam to fail very badly. But if you have the shear reinforcement, you cannot see much of these cracks, or you cannot see any large visible crack. So that's why this shear reinforcement is very pivotal for improving the shear strength of your beam. Okay, now let's come to our discussion again. Now, just think about the forces that we'll have in this particular. So you have the cracks here, and you take the section here. You take a section like this. Okay, you take a section like this. So in this section, what will be the forces? The internal forces and the external forces. The external forces will be, if the beam is a 4-point loaded beam. Okay, so you have, load in this point, you have load in this point, and you may have, you know the other part of the beam is not shown here. So you have a support here, say for example, and you have a support here. So in this part of the beam, the loads that you have, this load and this reaction in the support. So the load is here P1, the reaction is RL, say for example. So these two will then be the external forces. And what will be the internal forces? The internal forces will be the compressive force on the concrete, obviously, and this is the effective part of the concrete. So this will take the compressive force because the rest of the part is cracked. Okay, the rest of the part, this part is cracked, this whole part is cracked, so this will not take any compression. So the only top part will take the compression. So the compressive force will be Cc, and this y, this y will be the depth of the compression block. Okay, the depth of the compression block is, say for example, y. And obviously the tensile force will be taken by the longitudinal reinforcement. Okay, and because this part is cracked, concrete will not take either compression or tension. So the tensile strength on the steel reinforcement is, say for example, Ts. Okay, now the concrete will also take some shear force. Say for example, the shear force in concrete is Vc. The shear force in concrete is Vc, and the shear force in the longitudinal reinforcement, the steel reinforcement, is Vd. So now these will be your internal forces: this Cc, Vc, Vd, and Ts. Now, here is one point to understand in this particular case. This section is not a vertical section. This is an an ununiform section or irregular section, right? In this section, the tensile force on steel and shear force on steel, they actually work at this point B, this point B, and there is a gap in between point B and point A because the section is irregular. That's why the section is not a vertical section. At A point, the forces on concrete will work. What are the forces in concrete? This Vc, the shear force on concrete, and the compressive force Cc. So these two forces will work at point A. And as I said that this A and B, they do not lie in the same vertical plane. Rather, they have a distance of h in between them. So B and A has a distance of h in between them. Now, if I consider these forces, okay, I can write down the total external shear force will be, you can calculate the total external shear force from the external forces, right? The external shear force, the total external shear force will be what? Just the reaction force, minus the the load at the point load at this point. So RL minus P1, or in other words, because these are opposite forces, if you just take the difference, you will get the external shear force. So the external shear force will be RL minus P1. The internal shear force will be nothing but the summation of the shear force on concrete and shear force on steel, right? So shear force on concrete is Vc and shear force on steel is Vd. That's why the internal shear force will be simply Vc plus Vd. And these external internal shear force, they should be equal to keep the entire structure in static equilibrium. The V external and V internal, or the external shear force and internal shear force, should be equal. So in in that case, what we can say, RL, okay, minus P1 will be equal to VC plus VD, okay, or VC plus VD will be equal to V external, okay. So from this we can write VC equals V external minus VD. Just take the VD on other side, so this equation will become VC equal to V external minus VD. Now VD, the shear force on the steel, okay, steel reinforcement, it will be very small because the steel section is very small. That's why the shear force on the steel reinforcement will be very small. So if you have a um, say for example, if the beam section is like this, okay, and the steel reinforcements are like this, all right, and this is the stirrup, say for example. Oh, sorry, this is not, this is without the stirrup. So in this particular case we are not considering the stirrup. So this is for a beam with longitudinal reinforcement only without any stirrup. So in that case you have the longitudinal reinforcement only. So this VD will work in those two reinforcements, right? So these two reinforcements, the total of these two, the total forces on these two reinforcement will become VD, okay. Now because the area of these reinforcements are very small, the value of VD will also be small. So what we can do, we can neglect this VD, okay, we can neglect this VD. In that case VC will simply become equal to V external, and we see, as we said, that V external is nothing but RL minus P1. So you can write VC equals RL minus P1. Now if you take moment, okay, at point A, okay, if you take moment at point A, okay, then to calculate the external a moment, in that case you need to consider this force and this force, all right, and you take the moment at point A. In that case the value of the moment will be simply this force times this distance. So distance from A to this force is XA, okay, so RL minus XA, and this force times this distance. And because they are acting on opposite direction, this is acting uh, in clockwise direction, and this force will be rotating in counterclockwise direction. So the equation will be, for calculating the external moment, the equation will be RL times XA minus P1 times this distance, and this distance is what? XA minus X1, right? XA minus X1. So XA minus X1, this is this distance. So the equation will be RL times XA minus P1 times XA minus X1, okay, this distance, because this distance will become XA minus X1, that's why. So that's what we have found here. So M external can be written with this equation, and the internal moment, because internal moment should be equal to external moment, so you need to calculate the internal moment as well. Internal moment will be what? If you take the internal moment at point A, say for example, okay, internal moment at point A, in that case, because these two forces VC and CC, they are working at point A, because of these two forces the moment will be 0. The other two internal forces are TS and VD, so these two will create the internal moment at point A. So at point A, because of TS and VD, the internal moment will be what? TS times Z. Z is the moment arm, the distance between CC and TS, that is the Z. So moment at point A will be TS times Z, and this is counterclockwise. And VD, this will also be counterclockwise. So TS times Z plus VD times H. Okay, VD times H. So this will be the internal moment. So that is the internal moment at point A. Now external moment uh, at point B and internal moment at point A will be equal. Okay. Sorry, এটা হচ্ছে এখানে একটা জিনিস একটু, this is the external moment at point A. Okay. So the external moment at point A and internal moment at point A will be equal. Okay. Now the internal moment at point A is this one. All right, this one. So if I simply write M external A here, and if I want to calculate the value of TSB, okay, TSB means TS at point B. That is TSB. Okay. And VDB means VD at point B. So TSB or VDB and TS and VD, they are same. Like you can write TS or you can write TSB. That's the same thing. So if I just calculate the value of TSB will be this equation. And as I said before that, the shear force on the steel reinforcement VD will be small, and you can ignore this force. Then the equation of TSB will be this equation, this one. Okay. Now, before cracking and after cracking. Before cracking, the shear stress in concrete was what? V external divided by BD. Okay. Because before cracking, you had all the area effective. So if you just simply divide the shear force by your area of concrete, or if you divide it by BD, in that case you can get the shear stress in concrete before cracking. But after cracking, you have only this much area effective. The area with a depth of Y, this much area is effective now. So the after cracking, the shear stress in concrete will become V external divided by Y into B. Okay, instead of D, it will become Y into B. B is the width of the beam, and Y is the B is the width of the beam. B is the width of the beam, and Y is the effective depth of the compression block, or the depth available for the compression block. Okay. Now you can see that because this Y value is very small compared to D. Okay. Now the area available for resisting the shear force, that is the V external, has reduced in that case. In this case, so if you divide V external by a smaller area, in that case the shear stress will become large. So as the crack propagates, as the wave crack or the shear crack propagates, the effective area available for resisting the shear force becomes smaller, and the shear stress on the concrete will also become large. All right. So this is one thing that I wanted to mention. And the other thing is the neutral axis. The neutral axis will also will also move upward because of the crack. What will happen? The compression block will become narrower. The depth of the compression block is now Y. So if the crack propagates further upward, the depth of the compression block will again reduce, and that's why the neutral axis will also move upward. So similar to the flexural cracks, the wave cracks, the shear cracks can also cause the neutral axis to move upward. That is very important to understand. We discussed that for flexure cracks, when move upwards, okay, আমরা যখন ফ্লেক্সারের জন্য বিমের যখন ডিজাইন করছি তার আগে we discussed many times that when the flexure cracks move upwards, then the neutral axis location also moves upward, or in other words, the compression block becomes narrower. Similarly, if the diagonal crack moves upward, obviously the compression block will also become narrower, and the result will be the neutral axis will move upward as well. আচ্ছা, আরেকটা জিনিস সেটা হচ্ছে the stress in steel, which is TS, the stress in steel, the tensile stress in steel will also increase. এটা কিভাবে? এটা if the crack move upwards, then the tensile stress on steel will also become higher. এর কারণটা হচ্ছে if I explain here, okay, so if, say for example, if your crack has propagated to this distance, a distance পর্যন্ত আসে, in that case what will happen? This area will be the effective area for resisting the compression, right? So this will be your compression block in that case. So আমি জাস্ট এই যে এখানে আমার ফিগারে যেটা আমার ছবির ফিগারে যেটা দেখানো হয়েছে তার একটা ইন্টারমিডিয়েট একটা কেস আমি জাস্ট চিন্তা করতেছি, ওকে, আর একটা ইন্টারমিডিয়েট কেস আমি চিন্তা করতেছি। সো ছবিতে আমার দেখানো হয়েছে যে the crack has moved up to this point, এই পয়েন্ট পর্যন্ত, right? Now if I think that the crack has moved up to this point, obviously the crack will move up to this point first and then this will move up to this point. With the a point আসে, in that case, say for example, the compression block is a bit higher and it is, say for example, is y1, say for example, okay, ধরে নিচ্ছি, although this will be a little bit higher কারণ নিউট্রাল এক্সিসটা এত নিচে থাকবে না, একটু উপরে থাকবে হয়তো, বাট ধরে নিচ্ছে যে কম্প্রেশন ব্লকটা আমার এই পর্যন্ত, and in this case the compression block has reduced to y. Now in this case, এই কেসে, okay, if I calculate the value of TS যখন আমার ক্র্যাকটা এই পর্যন্ত আসে, when it has moved up to this point, okay, আচ্ছা আগে এটা বলি আমার এখানে যেটা আছে, ওকে, আমার এখানে যে ক্র্যাকটা এখানে দেখাচ্ছে যে আমার ক্র্যাকটা এই পর্যন্ত আসে, রাইট, এই পয়েন্ট পর্যন্ত আসে, হ্যাঁ, সো এই পয়েন্ট পর্যন্ত আসছে, হ্যাঁ, সো এই পয়েন্টে যখন আসবে তখন আমার টিএস এর ভ্যালুটা কত হবে? টিএস এর ভ্যালুটা আমরা এখানে ক্যালকুলেট করছি, এটা দেখি। সো টিএস জাস্ট টেক, এই যে এখানে ক্যালকুলেট করা হয়েছে, টিএসবি ইজ সরি আচ্ছা আফটার ক্র্যাক যখন আমার ক্র্যাকটা এই পর্যন্ত আসছে, ইন দ্যাট কেস we calculated the value of TSB to be m external at point A divided by Z. Okay, m external at point A divided by Z. So now before crack, যখন আমার ক্র্যাক ফর্মই করে নাই, ধরো এইখানে যখন ক্র্যাক ফর্ম করে নাই তখন আমার এই সেকশনটা পুরোটাই ইফেক্টিভ থাকবে, and B and A, their distance will become 0. A point and B pointed distance will become 0. In that case, কি হবে? In that case, the moment at, the value of TS, you can calculate with the, this or other, in other words, this M external at point B and M external at point A will become similar, will become equal. যেহেতু আমার এ আর বি পয়েন্টে একই লাইনে আসবে চলে, তাহলে এম এক্সটার্নাল এট পয়েন্ট এ এন্ড এম এক্সটার্নাল এট পয়েন্ট বি উইল বিকাম ইকুয়াল। হ্যাঁ, কিন্তু যদি আমার ক্র্যাকটা প্রোপাগেট করে এদিকে আসে, যত বেশি উপরে উঠবে তত বেশি এ পয়েন্টটা, ক্র্যাক যত বেশি উপরে উঠবে তত এ পয়েন্টটা বি থেকে দূরে যাবে, রাইট? যখন এখানে ছিল তখন আরেকটু কাছে ছিল বি এর, এখানে যখন গেছে আরো দূরে গেছে, আরো উপরে গেলে আরো দূরে চলে যাবে। সো হোয়াট উইল হ্যাপেন, this A point will become further, will go far away from the, will move far away from the from point B, and the result will be the moment at point A will increase. The moment at point A will be larger, okay, compared to the moment at point B. যত দূরে যাবে A পয়েন্টটা তত আমার A পয়েন্টের মোমেন্ট আর B পয়েন্টের মোমেন্টের ডিফারেন্সটাও বাড়তে থাকবে, অথবা A পয়েন্টের মানে ইন আদার ওয়ার্ডস A পয়েন্টের ভ্যালুটা B পয়েন্টের ভ্যালুর চেয়ে, B পয়েন্টের মোমেন্টের ভ্যালুর চেয়ে বেশি লার্জ হতে থাকবে। এটা খুবই ইম্পর্টেন্ট বোঝার জন্য, এটা বুঝতে পারতেছো কিনা জানি না, আমি আরেকবার একটু বলি। যত আমার ক্র্যাকটা উপরে উঠবে, the more the point A will move further away from point B, and the value of moment at point A will also become higher compared to the moment at point B. So the further A point moves apart from point B, the larger will be the value of moment at point A compared to the value of moment at point B. এটার কারণটা কি, কেন লার্জ হবে? বিকজ আমার এই মোমেন্ট, এক্সটার্নাল মোমেন্টগুলি আসলে এই ফোর্সগুলি থেকে ডিস্টেন্সের উপর ডিপেন্ডেন্ট, রাইট? শোনা যাচ্ছে কথা? হ্যালো, কথা শোনা যায়?
জি স্যার।
সো আমার এই যে মোমেন্টগুলি, এক্সটার্নাল মোমেন্টগুলি, দি মোমেন্টস আর ডিপেন্ডেন্ট অন দ্য ডিস্টেন্স and the value of the forces. The forces যদি constant থাকে, if the distance becomes larger, what will be the result? The moment will also become large. So যখন ডিস্টেন্সটা A পয়েন্ট যত আমার B পয়েন্ট থেকে মুভ করবে তত আমার এই ডিস্টেন্সটা বেড়ে যাবে, and the value of moment at point A will also become larger in that case. So যদি মোমেন্টের ভ্যালুটা লার্জ হয়ে যায় তাহলে আমার এখানে দেখো TS যখন আমার ক্র্যাক করছে, when the crack already formed, the value of TSB will be equal to M external at point A, right? So A point এ মোমেন্টের ভ্যালুটা obviously B point এ মোমেন্টের ভ্যালুর চেয়ে বেশি। সো যত আমার যত আমার প্রোপাগেট করতেছে ক্র্যাকটা, তত আমার M এর ভ্যালুটা MB এর চেয়ে বেশি হচ্ছে, and ততই আমার TS এর ভ্যালুটাও বেড়ে যাচ্ছে। কারণ আফটার ক্র্যাক, this is the equation, and before crack, because A আর B same point, A আর B same পয়েন্টে থাকবে বিফোর ক্র্যাক, সেম পয়েন্ট মানে সেম সেকশনে থাকবে, হ্যাঁ একই সেকশনে থাকতো, বিফোর ক্র্যাক একই সেকশনে থাকতো, তখন আমার এম এর ভ্যালুটা এম বি এর সমান হয়ে যেত। যত বেশি দূরে যাবে তত বেশি এম এর ভ্যালুটা এম বি এর চেয়ে বড় হবে, যত বড় হবে তত আমার টিএস এর ভ্যালুটাও বড় হয়ে যাবে। তার মানে in simple words, if the crack move upwards, the tensile stress on steel will also increase. So because of the shear crack, okay, the tensile stress in steel can also increase. That is the conclusion. Shear crack এর কারণে tensile stress in steel can also increase. So this is one thing that we understand. And the last thing that I should explain is the dowel action. This dowel action will happen because the shear force on steel will, this will try to split the bottom part of the concrete, okay, try to separate the bottom part of the concrete from the top part. যখন এই shear crack already form করবে তখন এই shear ফোর্সের কারণে, স্টিলের উপর shear ফোর্সের কারণে সে নিচের কনক্রিটটাকে টপ কনক্রিটের পার্ট থেকে আলাদা করে দেওয়ার চেষ্টা করতে থাকবে, and for that reason the shear crack, when it reaches the longitudinal reinforcement, it will not propagate further to the down. Rather, it, because of this dowel action কি করতেছে, the steel reinforcement is trying to separate the concrete. Because of this shear force, it is trying to separate or split the concrete from the bottom from the top of the concrete. ঠিক আছে, bottom concrete কে top concrete থেকে split করে দিতে যাচ্ছে. And for this reason, the shear crack, when it reaches the longitudinal reinforcement, it will move parallel to the longitudinal reinforcement. Instead of going downward, it will move parallel to the longitudinal reinforcement. So this is the dowel action. আচ্ছা, এটা গেল. And then, so what we discussed in this section, the summary, the shear failure is more rapid compared to the flexural failure, and that's why we need to use a a lower strength reduction factor. That means the strength capacity will become the design moment, the design shear capacity. For calculating the design shear capacity, you have to use a smaller factor so that the capacity itself becomes smaller. হ্যাঁ, আর ফ্লেক্সারের ক্ষেত্রে we said that we have to use 0.9. Okay, the pressure can for beam or for slab. Okay, use 0.8 to allow for higher safety factor. And আরেকটা জিনিস সেটা হচ্ছে আমার যখন when we take the shear force for design, okay, when we go to the design, we will see when we take the shear force for the design, we do not take the shear force at the support, although the shear force at the support is the maximum shear force. But it is seen normally that the shear crack, okay, the shear crack টা form করে, that shear crack normally forms at a distance of effective depth d from the support. তার মানে সাপোর্ট থেকে একটা ডেপথ d ডিস্টেন্সে normally the shear cracks start to form. Okay, the shear cracks normally do not form exactly at the support, rather it forms at a distance of d, and d is simply equal to the effective depth, the distance from the top to the center of the longitudinal reinforcement, that is your effective depth. Okay, so you can, for that reason, what you can do, you can take the shear force at a distance d in your shear force diagram. Rather than taking the shear force at the support, you can take the shear force at a point at a distance d in your shear force diagram, and you can consider that shear force as your design shear force. Okay, আচ্ছা, এই যে ডি ডিস্টেন্সে কাজ করে, এটা আমরা এই ফিগারেও দেখছি, এখানে একটু দেখাই তোমাদেরকে. So you can see that for this figure, the support is here, right? And if the longitudinal reinforcement is, say for example here, roughly this will be your effective depth d. And when the crack initiated, crack initiation, the wave shear crack will be initiated near the neutral axis, as I said, and the center of the, or the the point at which this crack intersects the neutral axis, that point is roughly at a distance of d from the support. Yes, support থেকে d distance দূরে roughly. So you can understand that the shear force, or the shear crack normally they do not initiate at the support, rather they initiate near, at a distance at a distance of d from the support. Okay, at a distance of d from the support. That's why you can take the shear force value at a distance d in your shear diagram to calculate the design shear force. Okay. Now we have a problem. We will inshallah do this problem. In this problem, what we are asked, we have to check. So a beam is given, and this beam rests on brick walls. So this beam is a simply supported beam, you can say, as it rests on steel wall. For this beam, you have to check whether you need the shear reinforcement or not. Okay? Whether the concrete in this beam is obviously there is longitudinal reinforcement. So the concrete and the longitudinal reinforcement, whether this is enough for resisting the shear in this particular beam. Okay. If the concrete is enough for resisting the shear force, then obviously you don't need the shear reinforcement. So you have been asked to check that whether you are actually required to provide the shear reinforcement in this particular beam. In this case, what you can do, you can first draw the shear force diagram and the bending moment diagram. So this will be the shear force diagram and the bending moment diagram. Okay, and you can calculate the value of the shear force at a distance d. Yes, as we said that the for calculating the design shear force, we take a value at a distance d rather than taking a value at the support, exactly like the support. Okay, so the distance d is 23 inch, as the depth of the beam is given as 25. Okay, and the effective depth is 23. So you have a cover of 2 inch cover you have. Okay, and from that the value of effective depth will be 23 inch, and if you convert it into feet, the value of the effective depth will be 1.92 feet. Okay, and if you calculate the shear force value at this particular distance, okay, you can do this using these equations. You already did this in your mechanics class, I believe. In your mechanics class, you are supposed to cover these things. Your load value or your shear force, sorry, or your load, the load value, the uniformly distributed load value on your beam, the uniformly distributed load value on your beam is nothing but the first derivative of the shear force. I think you know this equation. This should be covered in the mechanics, analytical mechanics, or the solid mechanics, any of these two. So the first derivative of the shear force is nothing but the uniformly distributed load on top of the beam. And why this negative sign? Negative sign because the uniformly distributed load is downward. That's why. Okay. If it is upward, then obviously you will have positive load. Okay. So in that case, if you take the first integral of this equation, the first integral will be this one. Okay, and you have the integration coefficient of c, and when x equals 0, okay, when x equals 0, obviously the shear force will be equal to the value of the reaction. Okay, so if this is my say for example this is 1900, okay, pound per feet. So the reaction will be what? Reaction at the supports. If I write the reaction at the supports, this reaction, sorry, this is one reaction and this is another.
So WL/2 হবে না স্যার?
হ্যাঁ, WL/2. So WL/2 যদি সেটা আমরা কত হবে? 1900 divided by 1900 into 20 divided by 2, right? Simply 1900 divided by 20 times 2. So সেটার ভ্যালু আমার কি হবে? ক্যালকুলেট করো।
So 19,000.
Yeah, simply 1900. Yeah. Sorry, 90,000. 19,000. Yeah. So this will be your reaction. And obviously from the shear force diagram, you know that the first shear force here, the shear force of support is equal to the value of the reaction. So this is 19,000, তাই না? 19,000. So this is 19,000. এটাই হচ্ছে আমার shear force এর value. Shear force এর value 19,000. And from these you can calculate the value of C. So এখানে আমি যদি V এর ভ্যালুটা বসাই দেই আর X এর ভ্যালুটা বসাই দিই, X will be equal to 0, then you can get the value of C. Now if you plug in this value of C, okay, C এর ভ্যালুটা যদি আমি এখানে বসাই দিই আবার, তাহলে you get the relationship in between X and V. So my design shear force will be at a distance of 1.92 feet. So আমি যদি X এর ভ্যালু এখন 1.92 বসাই দেই, just simply, then we can get the value of my design shear force. Right? Simple. And after I get the design shear force, or maybe after I can calculate the value of the moment. Okay, and the value of moment will be nothing but the second derivative of these particular, sorry, the first derivative of this particular equation. The first derivative of this particular equation. So এটা আমার ইকুয়েশনটা, and then you get the first integral. The first integral of this equation will be nothing but this one. Okay, and you can get the value of C. Okay, if you take the bending moment at x equals 0, then you can get the value of C. Obviously at x equals 0, from the bending moment diagram you can see that the bending moment will be 0. So at x equals 0, m equals 0, so value of C will also be 0. Just plug in the value of m and x, and you get the value of C to be equal to 0. And then when you know the value of C, you plug in the value of C in this equation and get the relationship in between m and x. So at a distance x, or at a distance of 1.92, the value of m will be 32,978. You can just plug in the value of x 1.92 and you get the value of m at a distance of d. Effective depth d তে কত m সেটা আমি পেয়ে যাব। আচ্ছা, এই জিনিসটা আমি এভাবে বের করছি, but you can also take a section here, right, and simply calculate the, because this is simply supported beam, এখানে এটা একটা determinate structure, so you can just take a section here and then you can calculate the bending moment diagram and shear force diagram. If you know the reaction, you can calculate the bending moment diagram and shear force diagram. বুঝা গেছে? এটাও করতে পারো। You can also calculate from the value from the shear force diagram and bending moment diagram. তুমি সেকশন নিয়ে বেন্ডিং মোমেন্টের ভ্যালু আর শেয়ার ফোর্সের ভ্যালুটা বের করতে পারো, সেকশন নিয়ে বেন্ডিং মোমেন্ট ডায়াগ্রাম অথবা শেয়ার ফোর্স ডায়াগ্রাম থেকেও বের করতে পারো, or you can use these equations, or you can use, so you have three ways. You can do the same thing in three ways. It's up to you which way you want to do this. And then the concrete shear strength will be calculated using this equation. This equation we already discussed. So just plug in the value of your design shear force and the moment at the location of design shear force, that is the moment at a distance of d. Okay, just plug in these values. So your design shear force 52, so you plug in this value, and your moment at the section of design shear force is 32,978. You just plug in this value, and you know all the other values. You calculate, because you have 3 number 9 bar. 1 number 9 bar is 1 square inch. The area of 1 number 9 bar is 1 square inch. So the area of 3 number 9 bars will be simply 3 square inch. Okay, and the reinforcement ratio will be AS by BD. So 3 times 1, this is the reinforcement area, and B is 10 and D is 23. Okay, you get the value of your row, you plug in the value of your row, and your FC prime is given is 30,000. Sorry, 3,000. Okay, FC prime is 3,000, so you plug in the value of your FC prime. আচ্ছা, এখানে 12 দিয়ে মাল্টিপ্লাই করছি জাস্ট টু মেক ইট ইন ইঞ্চ। এখানে যে এম এর ভ্যালুটা পাউন্ড ফিটে আছে, এটাকে ইঞ্চে করার জন্য I multiplied it by 12 because all the other things are in inch. Say for example FC prime এটা ইঞ্চে আছে, right? FC prime টা ইঞ্চে আছে, PSI তে আছে, পাউন্ড পার স্কয়ার ইঞ্চ আছে। আচ্ছা, এরপরে আমি সিম্পলি if I take the value, this value will give you 133 PSI. এটা তোমার চেক করতে হবে যে এই ভ্যালুটা এটা চেয়ে বড় কিনা। যদি বড় হয় তাহলে 3.5 FC prime দিয়ে যে ভ্যালুটা আসবে সেটা নিতে হবে, আর যদি ছোট হয় তাহলে ছোটটা নেবে obviously। ঠিক আছে? So your VCR is 133 PSI. Okay. Now if I want to calculate the force, shear force, so this is my strength, shear strength. তাহলে shear force টা কি হবে? এই স্ট্রেসটাকে if I multiply it by BD, then we can get the value of shear force. So simply তাই করা হয়েছে, 133 multiplied by B is 10 and D is 23. তাতে মাল্টিপ্লাই করলে you get the value of your shear force. shear stress থেকে shear force পেলাম, and this shear force obviously if it is greater than the design shear force, obviously the concrete will be কি হবে able to take the shear force alone without the help of the shear reinforcement. তার মানে এটা হচ্ছে আমার কনক্রিটের shear resistance, এটা স্ট্রেংথ, আর এটা হচ্ছে এতটুকু ফোর্স কনক্রিট নিতে পারবে। আর আমার ডিজাইন শেয়ার ফোর্স যেটা, সেটা হচ্ছে আসলে কতটুকু শেয়ার ফোর্স এই এক্সটার্নাল লোডিং এর কারণে আছে। এক্সটার্নাল লোডিং যে 1900 পাউন্ড পার ফিট এক্সটার্নাল লোডিং, সেটার কারণে আমার যে শেয়ার ফোর্স আসছে ডিজাইন শেয়ার ফোর্স, সেটা হচ্ছে এটা। আর কনক্রিট কতটুকু নিতে পারবে? 30,590. obviously this is greater than this one, so your concrete can take the shear force, but obviously you need to check whether this is sufficiently high or not. শুধু একটু বেশি তাতেই যে আমি রিইনফোর্সমেন্ট দিব না তেমন না। হ্যাঁ, আমার দেখতে হবে ফ্যাক্টর অফ সেফটিটা কত। তো ফ্যাক্টর অফ সেফটি কত সেটা ক্যালকুলেট করলে সিম্পলি ডিভাইড দিস ভ্যালু বাই দিস ভ্যালু। সো 30,590 ডিভাইডেড বাই 15,352 যদি আমি করি, in that case we get a value of roughly 2. So factor of safety 2 is good enough. So obviously because the factor of safety is 2, you don't need to provide shear reinforcement, and the concrete will be able to take the shear reinforcement by itself without the help of the shear reinforcement. এই পর্যন্ত কি বোঝা গেছে?
জি স্যার।
আচ্ছা, সেকশন বি এ তোমরা কি আসছো? সেকশন বি?
জি স্যার।
আচ্ছা, ঠিক আছে। সো এখানে আমরা এরপরে আসবো আপ টু দিস all the discussion was without the reinforcement. হ্যাঁ বলো
স্যার। যদি মানে দেখা গেছে যে মানে ভি ডিজাইনটা স্যাটিসফাইড হয়, যে ভি ক্র্যাকটা ভি ডিজাইনের চেয়ে বড় আসে, কিন্তু দেখা গেল যে ফ্যাক্টর অফ সেফটিটা স্যাটিসফাই হচ্ছে না, তখন মানে
আমাদের শেয়ার reinforcement প্রোভাইড করতে হবে, সেটা ডিসকাশনে এখন আমরা আসবো। So up to this all this discussion was without the shear reinforcement. Okay, so up to slide 22 all the discussion was without shear reinforcement. Now what will happen if you introduce shear reinforcement? Yes, সেখানে আমরা এখন আসবো। আচ্ছা, okay, now if your the question was from Amir, the question was if the design shear force, okay, is larger than the shear force capacity of the concrete. Okay, so এখানে এই জিনিসটাই ডিসকাস করা হচ্ছে। যদি আমার ডিজাইন শেয়ার স্ট্রেংথ ভিডি, স্মল ভিডি মানে হচ্ছে এখানে ডিজাইন শেয়ার স্ট্রেংথ, ডিজাইন শেয়ার স্ট্রেংথ অর ডিজাইন শেয়ার স্ট্রেস, স্ট্রেংথ বলা হচ্ছে, স্ট্রেস বললে মনে হয় একটু বুঝতে সুবিধা হবে, বিকজ দিস ইজ দ্য স্ট্রেস কামিং ফ্রম দ্য এক্সটার্নাল লোড. So the design shear stress, if it is higher than the shear strength of concrete, in that case you need to provide the shear reinforcement, okay, or the web reinforcement. Web reinforcement or shear reinforcement, we will change, we will use them interchangeably, they are the same thing. Okay, web reinforcement or shear reinforcement. Obviously for the calculating the shear strength contribution from concrete, this is the equation we already discussed this equation. But in addition to these strength provided by the concrete, you need support from the stirrups, and the stirrups you can provide in many ways. You can provide the stirrups vertically like this, and you can provide the stirrups in an inclined way like this. Okay, but this is the more common practice, এইভাবে বেশি দেওয়া হয়, because this will give you better bonding in between the longitudinal bars and the stirrups. লংজিটিউডাল বার এবং স্টিরাপের সাথে যে টাইটা, এটা বেটার হবে এখানে এরকম ভার্টিক্যালি যদি প্লেস করা হয়। বাট you can also provide in this inclined angle to resist the shear force. Both of them, either you provide them vertically or you provide them in an inclined fashion, both of them will be handling the shear cracks. They will be sufficient for resisting the shear cracks. Normally the shear reinforcement or stirrups we use number 3 or number 4 bars. Okay, normally we use number 3 or number 4 bars. Okay, acha, shear reinforcement normally they will not contribute to the overall performance of your beam before the formation of diagonal cracks. Okay, so যখন একটা crack or একটু form করবে, obviously the crack will be will not be very large in size because of the presence of this shear reinforcement. But when the crack is formed to some extent, একটা ছোট্ট যখন crack তৈরি হবে, তখন the shear reinforcement will be coming into the action. Okay, in that case the shear reinforcement will provide the resistance against the cracks from being bigger. আচ্ছা, এখানে তিনটা পয়েন্ট। পার্ট অফ দ্য shear force is resisted by the bars which transverse a particular crack. So obviously ধরো এখানে আমার এই যে ক্র্যাক যেখানে থাকবে সেই জায়গার shear reinforcement will be effective in resisting the shear crack from propagating further. Okay, so this is the one thing. Web reinforcement prevents the penetration of the diagonal cracks to the compression block of concrete. Obviously, if you have shear reinforcement, then the propagation of this block to the top will become less. Okay, because the shear reinforcement will hold the cracks from propagating upward. So compression ব্লকের দিকে বেশি যাবে না যদি shear reinforcementটা থাকে. And the shear reinforcement will also tie the longitudinal reinforcement. Okay, longitudinal reinforcement কে টাই করে রাখবে। যেমন এখানে একটা ছবি দেখানো হয়েছে, this is the longitudinal reinforcement. Okay, you can see the longitudinal reinforcement are surrounded by the shear reinforcement. এটা এইভাবে দেখানো হয়েছে, you can provide, but normally we have longitudinal reinforcement on top and in the bottom. Yes, আমাদের normally দুই পাশে আমরা longitudinal reinforcement ইউজ করি। হ্যাঁ, in this case you will usually tie this longitudinal reinforcements like this. We discussed this thing, and this tie should be at an angle of 135 degree. We discussed this thing as well. এবং এরকম tying, it is very good when you require resistance against earthquake. when you require better resistance against earthquake, then this type of tying of the longitudinal reinforcement with the shear reinforcement is very effective. So এটা হচ্ছে আমরা normally বেশি, this one we normally use more compared to the other ways that you can see in these figures. Okay, so these figures you can see that longitudinal reinforcement, they are not tied. Okay, they are untied. Okay, they are untied, all of them. But normally we use this type of tying. Okay, we use this type of tying in our structures. Normally in most of the structures you will see this one, because this is recommended for earthquake resistant design. Okay, আচ্ছা, আরেকটা জিনিস সেটা হচ্ছে when you want to bend the horizontal beam, horizontal bars, okay, if I want to bend the horizontal bars or if I want to bend the longitudinal bars, যেমন এখানে আমার যদি আমি এই পার্টিকুলার বিমের ক্ষেত্রে চিন্তা করি, the bending moment will be simply like this. Say for example, যদি simply supported beam হয়, the bending moment will be simply like this, right? So you don't need, because the moment is maximum in this particular region and you don't have much moment here. So what you can do, you can reduce the amount of reinforcement in this region. Moment এখানে যত বেশি না, you can reduce the amount of reinforcement in this region. So instead of using two bars, what you can do, you can take one bar, you can crank one bar. So one bar, so এরকম যদি এই জিনিসটা যদি আমার করা হয় সেক্ষেত্রে এরকম করা যেতে পারে। ধরো you have four bars in the bottom and two bars on the top. Two bars on the top, and you have four bars in the bottom. এরকম যদি থাকে, in that case what you can do, you can keep these two bars straight or you can continue these two bars like this one. এই যে দেখো এখানে একটা বার দেখানো হইতেছে যে পুরা কন্টিনিউ করা হয়েছে, রাইট? So you can take two of these bars straight. You can keep them continued throughout the whole span of the beam, and you can crank the other two bars. এই দুইটা বারকে তুমি ক্র্যাঙ্ক করতে পারো, দুইটা বারকে তুমি ক্র্যাঙ্ক করতে পারো, লাইক এখানে দেখানো হয়েছে। হ্যাঁ, এখানে মানে ফিগারে দেখানো হয়েছে, এই জিনিসটাকে দেখানো হয়েছে যে আমি দুইটা বারকে আমি ক্র্যাঙ্ক করছি, ওকে, আর দুইটা বার আমি কন্টিনিউ করছি থ্রু আউট দ্য স্প্যান। ইউ ক্যান ডু দিস when you don't need these two bars. I mean, when you don't have much moment near the support, you can crank these two bars to the top.
স্যার এটা যদি সিম্পলি সাপোর্টেড বিম হয় তাহলে
আমার এখানে নেগেটিভ মোমেন্ট, হ্যাঁ নেগেটিভ মোমেন্ট বেশি আসবে না, এটা ঠিক বলছো, কোশ্চেনটা ঠিকই করছো। ধরো কথার কথা এটা সিম্পলি সাপোর্টেড বিম না, ইন দ্যাট কেস আমার টপে তো রিইনফোর্সমেন্ট লাগবে, রাইট? আমার কথা আমার সিম্পলি সাপোর্টেড না বিম হয়ে এটা এই পাশে আমার ফিক্স সাপোর্ট, in that case obviously you need this top reinforcement. তখন আমার এখানে নেগেটিভ মোমেন্ট আসবে, এখানে পজিটিভ মোমেন্ট আসবে, তখন you need the top reinforcement. That's why you can crank some of the bars, okay, to the top. ক্র্যাঙ্কিংটা এমন ভাবে করা মানে করা যেতে পারে যেন আমার কর্নারে দুইটা বার থাকে। হ্যাঁ, এই যে আমি কন্টিনিউ করতেছি সেই বারগুলিকে কর্নারের বারগুলি যদি হয় সেক্ষেত্রে আমার স্টিরাপটা এই কর্নার বারগুলির এগেইনস্টে টাইড হয়ে থাকবে। The reason that I wanted to show you this figure, that you can do the cranking of these two middle bars instead of the corner bars, so that the tying of the stirrup can be done against the corner bars. এই যে কর্নার বারগুলি সেই দুটোকে তুমি লংগিটিউডনালি কন্টিনিউ করতে পারো, and you can do the cranking for the middle bars. Okay?
স্যার আমাদের 9:40 থেকে রেজাউল করিম স্যারের ক্লাস আছে
আমার ক্লাস কি শেষ হয়ে গেছে নাকি?
স্যার 9:40 পর্যন্ত আর কি।
ইন্নালিল্লাহ। আচ্ছা, তোমাদের অ্যাটেন্ডেন্স দিতে হবে, তাহলে আমি আজকে এই পর্যন্ত রাখি, এন্ড দেন উই উইল কন্টিনিউ ফ্রম দিস স্লাইড দ্য নেক্সট ক্লাস ইনশাআল্লাহ। তোমাদের অ্যাটেন্ডেন্সটা নেই একটু তাড়াতাড়ি করে।
স্যার
জি জি, হ্যাঁ বলো।
স্যার আমি আপনাকে মেইল করেছিলাম।
হ্যাঁ, তোমার মেইল দেখছি, কিন্তু তোমার মেইলের সব অ্যাটেন্ডেন্স আমি হয়তো কনসিডার করব না, হয়তো পার্শিয়ালি কিছু কনসিডার করা যেতে পারে।
থ্যাংক ইউ স্যার।
তোমার অ্যাবসেন্সের রিজন তো বলো নাই। অসুস্থ ছিল বা কোনো ফ্যামিলি রিজন ছিল?
জি স্যার। আচ্ছা স্যার, আমি মেনশন
মানে
করব।
আমার স্পেসিফিক ভাবে মেনশন করতে হবে না, জাস্ট জেনারেল টার্মসে মেনশন করলে হবে যে ফ্যামিলি রিজন ছিল বা আমি অসুস্থ ছিলাম বা বাসায় কেউ অসুস্থ ছিল, একটু জেনারেল টার্মসে বললেই হবে। হ্যাঁ,
ওকে স্যার।
আর তুমি অসুস্থ থাকলে তোমার এক ইয়ে লাগবে আর কি, মেডিকেল সার্টিফিকেট।
জি স্যার, বুঝতে পারছি।
সেটা বাইরে ডাক্তার হলেও সমস্যা নেই। আচ্ছা, আমরা একটু অ্যাটেন্ডেন্সটা নেই তাড়াতাড়ি করে। সেকশন বি এরটা আগে নিচ্ছি। হ্যাঁ, সেকশন বি।
স্যার সেকশন এর ক্লাস আছে এখন, আমাদের একটু আগে না।
আচ্ছা, তাহলে সেকশন এরটা আগে নেই, ঠিক আছে। 101
প্রেজেন্ট স্যার।
একটু দাঁড়াও, একটু একটু। ওকে, 102 102 103
প্রেজেন্ট স্যার।
106
প্রেজেন্ট স্যার।
107 108
ইয়েস স্যার।
9
Yes, sir.
10 12 15
Present, sir.
16 16 18
Present, sir. 18 present, sir.
22
প্রেজেন্ট স্যার।
23 23 24
ইয়েস স্যার।
26 29 30 30 31
Yes, sir,
31
31. Yes, sir,
32.
31.
32 33
Present, sir.
প্রেজেন্ট স্যার 32 প্রেজেন্ট।
35
Sir, 33
Yes,
present.
sir.
33 দিয়ে দিছি। 35
Yes, sir.
36 36
ইয়েস স্যার।
37
Yes, sir.
39 142
Yes, sir.
43
Present, sir.
44 44 45 46
Present, sir. 146.
47
প্রেজেন্ট স্যার।
48
প্রেজেন্ট স্যার।
49 50
প্রেজেন্ট স্যার।
51
Yes, sir.
52
ইয়েস স্যার।
55
প্রেজেন্ট স্যার।
58 60 62 63 63 64
প্রেজেন্ট স্যার।
67
Yes, sir.
8
প্রেজেন্ট স্যার।
ঠিক আছে।
Sir,
section
144 sir.
Sir.
Sir, message this is your mic on হচ্ছে না।
Sir, 149, oh, sir.
149 144। আচ্ছা, সেকশন এ যারা অ্যাটেন্ডেন্স পেয়ে গেছে তারা চলে যাও।
স্যার
আর কেউ
163 হচ্ছে যে
আচ্ছা, আর কোনো কেউ আছে এরকম মেসেজ দিছে?
So 102, sir.
102 ঠিক আছে, ওকে ওকে। সেকশন বি তাহলে আসো এখন। সেকশন বি, টু 01 201 3
প্রেজেন্ট স্যার।
5
Present, sir.
6 206 206 207
Present, sir.
211
Yes, sir.
214 14 14 15 16
Yes, sir.
17
Yes, sir.
20
Present, sir.
22
Present, sir.
23
Present, sir.
25
Present, sir.
26 26 28
Present, sir.
29 30 33
Yes, sir.
34
Present, sir.
35 37
Yes, sir.
38 39
Yes, sir.
40
Yes, sir.
41
Present, sir.
42 44 45 47
Yes, sir.
48 48 49
Present, sir.
50 51
Present, sir.
2 53
Yes, sir.
54
Present, sir.
55 56
Present, sir.
7
Present, sir.
58 59
Yes, sir.
60
Yes, sir.
61
Yes, sir.
2
Present, sir.
3
Present, sir.
5 66
Yes, sir.
কেউ বাদ দিয়েছো?
Sir,
Sir,
sir, sir.
245.
116.
একজন একজন করে বলো, হ্যাঁ বলো।
Sir, 245.
Sir, 116.
245 দিলাম, তারপরে
201.
Sir, 116.
11
6.
Sir, 201.
230.